Hello everybody, this is Unit 4, Covalent Bonding and IMFs. We're going to start Section 2, Introduction to Intermolecular Forces. So for this, I want you to be writing down on a piece of paper, on your notes, in your notebook, wherever. You're going to be writing down this information, and next class we're going to build on this information with the specifics of what each individual IMF is and how that IMF will impact the properties of the substances, like melting point, boiling point, that kind of thing. So it might be helpful for you to actually draw this picture that we have up here. Here we have two covalent compounds, HCl and another HCl. So we've got two molecules of hydrogen chlorine, hydrogen chloride, hydrogen monochloride up in there. And we are going to be looking at the attraction between the molecules. So in the past, we've been focusing on the bond itself. But now we're going to focus on why is this molecule attracted to this molecule. And that's where we're going to be looking at next. Not within the molecule itself, but one molecule attracted to another molecule. Okay, so let's review what we know about our bonds, our different types of bonds. We have our ionic bond, our covalent bond, and our metallic bond. So generally, when we're talking about the strength of a bond itself, the strength of the bond between the atoms, we put ionic compounds as the most strong. They have the highest melting point, the highest boiling point, and we know that's because of the crystal lattice. And because of that crystal lattice, it takes a lot of energy to move the molecules apart or the formula units apart and get a boiling point off of that to melt it. And then over here with covalent compounds don't form a crystal lattice structure like that. And because they don't form a crystal lattice structure, covalent compounds end up having being a little bit weaker. If I was going to compare a single formula unit and a single molecule, then the covalent bond is a little bit stronger. But because ionic compounds form that crystal lattice structure, overall they ended up being more strong than covalent. And then we get our metallic. And sometimes the covalent and the metallic can kind of swap places depending on specifically which elements we're talking about and what the molecule is. But ionic is always the highest. So intra versus inter. An intramolecular force is the force that holds the atoms together, and that is your bonds. Those are the ionic, covalent, and metallic bonds. Intra means within. So we're talking about the bonds within a molecule. Then we have the intermolecular forces. Inter is the attraction between molecules. Why is one water molecule attracted to another water molecule? And we have our three intermolecular forces, and they are called hydrogen bonding, which you already know that one. You learned that one in bio. London dispersion forces, and dipole-dipole interactions. So these are the three types of intermolecular forces that we're going to be discussing next class. And remember that inter means between. So intra is the bonds within the molecule, and inter is what's holding the molecules close together. So this is some images showing the intermolecular forces. So the intermolecular forces are the dotted lines holding one molecule next to another molecule. And the intramolecular forces, in this case our covalent bond, are what are holding the hydrogen atom close to the chlorine atom because they're sharing electrons. And then we have our water molecules down here. We have our intramolecular forces. Those are the bonds, the covalent bonds. And then holding one water molecule close to another water molecule is our intermolecular force, in that case, hydrogen bonding. So this is what causes molecules to be held close together, like a solid or a liquid, and why some things will boil faster than others. Some things will go into a gas easier than other things. It's all about how attracted the molecules are together. So this attraction that's holding the molecules together, there's different strengths of that, and that's what's going to cause some molecules to boil at really, really high temperatures and some molecules to boil at really, really low temperatures. So let's talk a little bit more about that. When we're talking about overcoming or breaking an intermolecular force, we need energy in order to do that. We have a force of attraction. It requires energy to overcome that force of attraction. If you're going to overcome an intramolecular force, this is our bonds. If we're going to break a bond and overcome it, that's called a chemical reaction. When you break the bonds between two atoms, that's when you have a chemical reaction. If I'm going to break up water into hydrogen atoms and oxygen atoms, I am actually creating a new substance. But when you're overcoming intermolecular forces, you're just changing the state of matter. State of matter. You're just causing the molecules to be more spread apart, or you're causing them to be closer together. So when we're looking at IMFs, we can't measure IMFs directly, but the way we can measure it is by looking at the physical properties like our melting points, our boiling points, and viscosity. Viscosity is how thick a liquid is. Something that is considered to be highly viscous would be something where the molecules are really, really close together. That would be like maple syrup. It's really, really thick. It's highly viscous. Because the molecules are really close together, it's pretty dense, even though it's still a liquid. Whereas something that is less viscous, low viscosity, would be like rubbing alcohol. Rubbing alcohol pours really easily, and that's because the molecules are not as attracted to each other, therefore they're not as close together, and it doesn't cause a very dense liquid like maple syrup or honey. If you have a really high melting point, that means that your molecules are really attracted to each other, and it took a lot of energy to break them. So here's a representation of what I just said. So melting point, remember, is taking a solid into a liquid, and it's the IMFs that are holding these particles close together. The IMFs are what are causing these particles to like to stay next to each other. And the stronger those IMFs are, the more energy it takes to separate them, causing us to have a higher melting point or a higher boiling point. So next class, we're going to get more into the specifics about hydrogen bonding, London dispersion forces, and dipole-dipole, and we're going to talk more about why they cause high melting point or boiling point, or how we know that one is stronger than another.